Welcome to Lecture 6 Interoperability in Software Architecture and Practice Arena. This is your Professor T. Freed Muhammad. We will be learning in this lecture together what is interoperability, interoperability general scenarios, tactics for interoperability, a design checklist for interoperability, and then we'll summarize all this together. Let's look into this with a use case. Interoperability is like a secret sauce that helps different systems and technologies work together seamlessly. Imagine a big grocery chain with multiple stores across the country. Each store has its own systems for managing inventory, sales, and customer data. Without interoperability, these systems might not be able to communicate with each other, leading to confusion and inefficiency. For example, if one store runs out of milk, it would be helpful if the system could automatically alert nearby stores to transfer some of their stock. This kind of smooth interaction between different systems is what interoperability aims to achieve, making the entire operation more efficient and responsive to customer needs. In the context of a grocery chain, interoperability can also enhance the customer experience. Think about a loyalty program where the customers earn points for every purchase. With interoperability, these points can be tracked and redeemed across all stores in the chain, not just one where the customer initially signed up. This means that no matter where a customer shops, their loyalty benefits follow them, creating a consistent and rewarding shopping experience. Additionally, interoperability allows for better data sharing, which can lead to personalized offers and recommendations based on a customer's purchase history, making their shopping trip more convenient and enjoyable. Interoperability plays a crucial role in the supply chain management of a grocery chain. It enables different parts of the supply chain, such as suppliers, warehouses, and stores, to communicate and coordinate effectively. For instance, when a store's inventory system is interoperable with the supplier system, it can automatically place orders when the stock runs low, ensuring that the shelves are always full. This is not only reducing the risk of stockouts, but also minimizes waste by preventing overstocking. Furthermore, interoperability can help in tracking the origin and journey of products, which is essential for food safety and quality control. In case of a recall, the grocery chain can quickly identify and remove affected products from all of its stores, safeguarding customers' health and maintaining trust in the brand. Interoperability general scenario. The portion of scenario is source, stimulus, artifact, environment, response measure. The possible values for the source is a system, a request to exchange information among the systems, as I just mentioned earlier. The artifact is the system that wishes to interoperate. Environment is systems wishing to interoperate are discovered at runtime or known prior to runtime. Response, one or more of the following. The request is appropriately rejected and appropriate entities, people, or systems are notified. The request is appropriately accepted and information is exchanged successfully. Last but not least, the request is logged by one or more of the involved systems. Response measure, one or more of the following. Percentage of information exchanges correctly processed, percentage of information exchanges correctly rejected. So this is pretty much the extension of what I just shared with you in terms of the grocery chain. Sample concrete interoperability scenario. So our vehicle information system sends our current location to the traffic monitoring system. The traffic monitoring system combines our location with our information, overlays this information on Google Map, and broadcasts it. Our location information is correctly included with a probability of 99.9%. Goal of interoperability tactics. Now let's look into this with an example. The goal of interoperability tactics in a grocery chain is to create a seamless and efficient ecosystem where all systems and technologies work together harmoniously. The primary objective is to improve operational efficiency by ensuring that data flows smoothly between different departments and locations. For instance, when the point of sale or POS system at the checkout counter is interoperable with the inventory management system, stock levels are updated in real time with each purchase. This immediate data synchronization helps in maintaining optimal inventory levels, reducing the chances of overstocking and stockouts, and ultimately leading to cost savings and improved customer satisfaction. Another key goal of interoperability tactics is to enhance customer experience and engagement. By integrating customer data across various touchpoints, such as in store purchases, online orders, and loyalty programs, the grocery chain can offer personalized recommendations and targeted promotions. For example, if a customer frequently buys gluten free products, the system can suggest new gluten free items or send them exclusive discounts. This level of personalization not only makes customers feel valued but also encourages repeat purchases and fosters brand loyalty. Furthermore, interoperability enables omnichannel retailing where customers can enjoy a consistent shopping experience whether they are in a physical store or on the website or using a mobile app. Interoperability tactics also aims to strengthen supply chain management and collaboration. When suppliers, distributors, and retailers use compatible systems, they can share information more easily and respond quickly to changes in demand or supply. For instance, if a particular product is selling faster than expected, the interoperable system can automatically notify suppliers to increase production and expedite delivery. This agility in supply chain helps in meeting customers' demands promptly and minimizing disruptions. Additionally, interoperability supports better traceability and transparency, which are crucial for ensuring food safety and complying with regulations. Moreover, the goal of interoperability tactics includes driving innovation and competitive advantage. By integrating emerging technologies like IoT, AI, and blockchain with existing systems, grocery chains can gain valuable insights and automate processes. For example, IoT sensors can monitor temperature and humidity levels in the storage facilities, ensuring that perishable items are kept in optimal conditions. AI algorithms can analyze sales data and predict future trends and optimize pricing strategies. Blockchain technology can provide a secure and transparent ledger for tracking the provenance of products, enhancing trust and credibility. By embracing these innovations, grocery chains can stay ahead of the competition and adapt to evolving retail landscape. So, information exchange requests, tactics of control, interoperability requests correctly handled, as just mentioned in the grocery chain example that I shared just with you. So these are the interoperability tactics that I just discussed with you in that entire scenario. The tactics have you have to locate and discover services when the information exchange request comes in. Then you manage interfaces, whether it's a mobile app, physical store location, or you are on the internet website. It orchestrates and tailor interface and request correctly handled in terms of your requirement that you are in need to work within the store. Locate. Discover service. Locate a service through searching a known directory service. There may be multiple levels of indirection in this location process. That is, a known location points to another location that in turn can be searched for a service. So let's look into this with an example. In the context of interoperability tactics, when a grocery chain, the term locate refers to the ability to identify and track the precise location of products, assets, and data across entire supply chain and retail network. This involves using technologies like RFID, radio frequency identification, GPS, global positioning system, and IoT, Internet of the Things. Sensors to monitor the movement of goods from the point of origin to the store shelves. For example, RFID tags can be attached to pallets or individual items, permitting the system to track their location in real time as they move through warehouses and distribution centers. This visibility helps in optimizing inventory management, reducing loss and theft, and ensuring that products are available where and when they are needed. Additionally, the ability to locate data and information is equally crucial. Interoperable systems can quickly retrieve and share data related to sales, customer preferences, and market trends, enabling better decision making and strategic planning. For instance, if the particular store is experiencing high demand for a seasonal product, the system can locate this data and trigger automatic restocking from the nearest warehouse. This responsiveness not only improves operational efficiency but also enhances customer satisfaction by ensuring that the popular items are always in stock. Furthermore, locating data across different systems allows for comprehensive analytics and reporting, providing insights that can drive growth and innovation in the grocery chain. Manage interfaces. Technically, we do orchestrate and tailor interfaces. So let's look into this with our grocery chain example in more depth. In the realm of interoperability, within a grocery chain, managing interfaces effectively is crucial for ensuring smooth operations and seamless data flow across various systems. The term orchestrate in this context refers to the coordination and integration of different technologies, platforms, and data sources to work together harmoniously. This involves setting up and maintaining APIs or application programming interfaces that allow disparate systems to communicate and exchange information. For example, the inventory management system needs to interface with the POS system to update stock levels in real time, while the customer relationship management or CRM system must integrate with the loyalty program to track and reward customer purchases. Effective orchestration ensures that these interfaces are reliable, secure, and efficient, minimizing data silos and reducing the risk of errors or delays. Orchestrating interfaces also involves implementing middleware solutions that act as intermediaries between different systems. Middleware can translate data formats, manage data flow, and ensure that all systems are synchronized. For instance, when a new product is added to the inventory, the middleware can update the e-commerce platform and in-store displays, and the marketing system simultaneously. The synchronization is essential for maintaining consistency across all customer touchpoints and internal processes. Additionally, orchestration requires continuous monitoring and optimization to adapt to changing business needs and technological advancements. By effectively managing interfaces, a grocery chain can enhance its operational agility, improve customer experience, and drive innovation across the organization. Tailoring the interfaces in the context of grocery chains interoperability strategy involves customizing the interactions between different systems to meet specific business needs to operation and operational requirements. This process ensures that each system can communicate effectively while accommodating unique data formats, workflows, and user requirements. For example, the interface between the warehouse management system and the transportation logistics platform might need to be tailored to account for specific shopping routes, delivery schedules, and vehicle capacities. By customizing these interfaces, the grocery chain can optimize its supply chain operations, reduce inefficiencies, and ensure that products are delivered to store in a timely manner. Additionally, tailoring interfaces can enhance the user experience for both employees and customers. For instance, the interface between the customer facing mobile app and the in store point of sale system can be tailored to provide seamless integration for mobile payments, digital coupons, and personalized recommendations. This customization not only makes the shopping experience more convenient but also encourages customer engagement and loyalty. Furthermore, tailoring interfaces to accommodate new technologies, such as AI driven analytics or IoT sensors, can drive innovation and provide valuable insights. By continuously adapting and refining these interfaces, the grocery chain can stay competitive and responsive to the evolving needs of the market and its customers. Hopefully, this has given you some good idea. So, design checklist for interoperability is allocation of responsibilities. Determine which of your system responsibilities will need to interoperate and with other systems. Ensure that responsibilities have been allocated to detect a request to interoperate with known or unknown external systems. Ensure that responsibilities have been allocated to accept a request, exchange information, reject a request, notify appropriate entities, people or systems, log the request for interoperability in untrusted environment. Logging for non-repudiation is essential. So overstocking or outstocking is the example that we just shared in that case. Let's look into this in the grocery chain aspect in a little bit more depth. When designing a checklist for interoperability within a grocery chain, the allocation of responsibilities is a crucial component that ensures accountability and clarity across various departments and stakeholders. This involves clearly defining who is responsible for managing and maintaining each interface, system, and data flow within the interoperability framework. For example, the IT department might be responsible for a technical integration of systems, while the inventory management team oversees the accuracy and timeliness of stock data. By allocating responsibilities, each team understands its role in maintaining the smooth operation of the interoperable ecosystem, reducing the risk of miscommunication, and ensuring that issues are addressed promptly. Moreover, the allocation of responsibilities should also consider the role of external partners, such as supplier and third party service providers. Clear agreements and service level agreements, or SLAs, should be established to outline the expectations and obligations of each party. For instance, suppliers might be responsible for providing accurate and timely data on product availability, while logistics partners ensure that the efficient transportation of goods. This collaborative approach fosters a sense of shared responsibility and encourage all stakeholders to work together towards common goals. Regular reviews and updates to the allocation of responsibilities are essential to adapt to changing business needs and technological advancements, ensuring that interoperability framework remains robust and effective. Now let's look into the coordination model with the same example. In the context of interoperability within a grocery chain, a coordination model is essential for ensuring that all systems, processes, and stakeholders work together effectively to achieve common goals. This model outlines strategies and mechanisms for synchronizing activities across different departments, such as procurement, inventory, sales, and customer service. For example, a coordination model might include regular cross functional meetings where representatives from each department discuss the inventory levels, upcoming promotions, and customer feedback. This collaborative approach helps in aligning efforts, identifying potential issues early, and making informed decisions that benefit the entire organization. Additionally, a coordination model should leverage technology to facilitate real time communication and data sharing, implementing a centralized platform that integrates data from various systems can provide a unified view of operations, enabling better coordination and quicker response times. For instance, if the marketing team plans a promotional campaign, the coordination model ensures that the inventory team is aware and prepared to handle increased demand. Similarly, customer service can be alerted to expect higher traffic to be ready to address any inquiries or issues. By forecasting a culture of collaboration and utilizing technology to support coordination, the grocery chain can enhance operational efficiency, improve customer satisfaction, and drive business growth. Now let's look into the data model. A well defined data model is crucial for ensuring that information is consistently understood, managed, and shared across various systems and departments. Our data model serves as a blueprint that outlines the structure, relationships, and rules governing the data used throughout the organization. It defines how data is organized and stored, ensuring that different systems can interpret and utilize the data accurately. For example, a data model might specify how product information such as item codes, descriptions, and prices is structured and linked to inventory levels and sales transactions. This standardization helps in maintaining data integrity and facilitates seamless data exchange between the systems, such as the point of sale or POS system, inventory management, and customer relationship management platforms. A robust data model supports efficient data integration and analytics. By defining clear data types, formats, and relationships, the data model enables different systems to communicate effectively, reducing the risk of data silos and inconsistencies. For instance, when the data model is aligned across the supply chain, it becomes easier to track products from suppliers to store shelves, enhancing visibility and traceability. This integrated view of data allows for comprehensive analytics, enabling the grocery chain to gain insights into sales trends, customer interfaces, and operational performance. These insights can inform strategic decisions such as optimizing inventory levels, personalizing marketing campaigns, and improving the overall customer experience. Additionally, a well designed data model is adaptable and scalable, accommodating changes in business requirements and technological advancements. As a grocery chain grows and evolves, the data model it becomes an evolution. In terms of the data model should be flexible enough to incorporate new data sources such as IoT sensors, social media feeds, and third-party data. This adaptability ensures that the data model remains relevant and supports the organization's long-term goals. Regular reviews and updates to the data model are essential to maintain its effectiveness and alignment with evolving needs of the business. By investing in a comprehensive data model, the grocery chain can enhance its operational efficiency, drive innovation, and achieve a competitive edge in the market. Now let's look into mapping among architectural elements in a little bit more depth. Mapping among architectural elements is a critical process that ensures all components of the IT infrastructure work together seamlessly. This involves identifying and defining how various systems, applications, and data sources interact and integrate with each other. Mapping begins with a comprehensive understanding of the existing architecture, including legacy systems, modern applications, and external interfaces. For instance, mapping might involve detailing how the inventory management system communicates with the point of sale system and how both systems exchange data with the customer relationship management platform or CRM platform. By creating a visual or conceptual map of these interactions, the grocery chain can identify potential bottlenecks, redundancies, and areas for improvement. Effective mapping also requires a clear understanding of data flows and dependencies. This involves tracing how data moves throughout the system from its point of origin to its final destination. For example, when the customer makes a purchase, the transaction data flows for the POS system to the inventory management system to update stock levels and then to the CRM system to update customer purchase history. Mapping these data flows help in ensuring data integrity and consistency across all systems. It also aids to identifying critical points where data transformation or validation is necessary, ensuring that data remains accurate and reliable as it moves through the architecture. Mapping among architectural elements support strategic planning and decision making. By visualizing the current states of the IT infrastructure, the grocery chain can better plan for future enhancements, such as integrating new technologies or scaling the current existing systems. For instance, if the chain plans to implement a new e commerce platform, mapping can help identify the necessary integrations with existing systems such as inventory and customer data. This proactive approach ensures that new additions to the architecture are seamlessly integrated, minimizing disruptions and maximizing benefits. Regularly updating the architectural map helps the organization stay agile and responsive to changing business needs and technological advancements. Now let's look into resource management. Effective resource management is essential for optimizing the use of assets, personnel, and technologies to achieve operational efficiency and the customer satisfaction. Resource management involves the strategic allocation and coordination of resources across various departments and systems to ensure that they are utilized effectively and aligned with business goals. For instance, managing inventory levels is a critical aspect of resource management where the goal is to maintain optimal stock levels to meet customer demand without overstocking or experiencing stockouts. This requires seamless integration between inventory management system and point of sale systems and supplier databases to ensure real time data exchange and accurate forecasting. Moreover, resource management extends to human resources where the focus is on allocating staff effectively across different state locations and departments. Interoperable systems can help in scheduling and mapping employee shifts based on predicted foot traffic and sales patterns. For example, data from POS system can be analyzed to identify peak hours, the point of sale system, permitting managers to schedule more staff during busy periods and reduce staffing during slower times. This not only optimizes labor costs but also ensures that customers receive prompt and efficient service. Additionally, resource management involves the efficient use of technological resources such as servers, networks, and software applications. By monitoring and managing these sources, the grocery chain can ensure that systems are performing optimally and can scale to meet increasing demands. Effective resource management also requires robust data analytics and reporting capabilities. By leveraging data from various interoperable systems, the grocery chain can gain insights into resource utilization patterns, identify areas of improvement, and make data driven decisions. For example, analyzing sales data can help in identifying fast moving and slow moving inventory, allowing for better inventory planning and reducing waste. Similarly, tracking energy consumption across stores can highlight opportunities for energy efficient practices, leading the cost savings and sustainability benefits. By implementing a comprehensive resource management strategy and grocery chain can enhance operational efficiency, improve customer satisfaction, and drive business growth. Now let's look into the binding time. Binding time refers to the moment when different systems, components, or services are integrated and begin to interact with each other. This concept is crucial for ensuring that all parts of the IT infrastructure work together seamlessly and efficiently. Binding time can occur at various stages, such as during system design, deployment, or even at runtime. For example, during the design phase, developers might integrate the inventory management system with the point of sale system to ensure real time updates on stock levels. This early binding ensures that the systems are compatible and can communicate effectively from the outset. However, binding time can also occur dynamically at runtime, permitting for greater flexibility and adaptability. For instance, when a new supplier is onboarded, the system might automatically integrate the supplier's data feed with existing inventory management system. This dynamic binding enables the grocery chain to quickly adapt to changes in the supply chain without disrupting ongoing operations. It also allows for the integration of new technologies or services, such as third-party delivery platforms, without requiring a complete overhaul of the existing systems. This flexibility is essential for staying competitive and rapidly evolving market. Effective management of binding time requires robust governance and monitoring mechanisms to ensure that integrations are uh, and sourceful as well as secure, reliable, and compliant with the industry standards. This involves establishing clear protocols and standards for data exchange, as well as implementing security measures to protect sensitive information. Regular testing and validation of integrations are also crucial to identify and address any issues that may arise. By carefully managing binding time, the grocery chain can enhance its operational agility, improve system performance, and drive innovation across the organization. This proactive approach ensures that the IT infrastructure remains responsive to changing business needs and technological advancements. The choice of technology for any of your chosen technologies, are they visible at interface boundary of the system? If so, what interoperability effects do they have? Do they support, undercut, or have no effect on the interoperability scenarios that apply to your system? Ensure that effects they have are acceptable. Consider technologies that are designed to support interoperability. Web services, can they be used to satisfy the interoperability requirements for the system under your control? Interoperability refers to the ability of systems to usefully exchange information. Achieving interoperability involves the relevant systems locating each other and then managing the interfaces so that they can exchange information. Hopefully, this has given you a good understanding of interoperability. Happy learning. See you in the next lecture.